This is a demonstration for xlock, the technology we are building at CleanTecher to create a more efficient electrical grid that can help integrate renewable technologies. For this demonstration, we are focusing on the user experience as they interface with our application. In addition to what you see here, we are also building an algorithm that will monitor the electrical grid while providing us with key analytics, as well as a smart switch that would sit behind the customer's meter and provide us with key information about their electricity usage habits. When the customer opens the application, they find themselves on this landing page. Here, the customer is informed about how much electricity they are currently using, as well as some analytics on their overall trends. When grid operators experience a higher than average demand for electricity but do not have sufficient supply, they are forced to choose between the customers who stay connected to the grid and those who are disconnected. This creates the conditions for a forced blackout. For customers who are connected to our application, they are alerted about this change in grid condition through our application. At this time, these customers can choose to either buy consumption from another person, meaning they would pay somebody else to turn their electricity off from the main grid and relieve that power supply back into the grid, or they can choose to turn their own supply off and be compensated for their inconvenience by another individual. In areas prone to blackouts, some customers have some amount of backup power supply. Those devices can now be used to ensure that customers who have turned off from the grid can actually have some residual electricity supply. Our application would monitor and resolve the transactions at the end of the blackout event. One main incentive for customers to use the platform is that if consumption is not rearranged, the entire area would experience a blackout. By engaging with the platform, customers can either make money or avoid electricity supply interruptions.